Hey everyone, Morgan here, and we are continuing on with the idea from page 5 in this outline. We're now going to focus on page 6. This is the particulate diagram for what happened in that titration that we just dealt with. So, assume that in that titration we only had 4 HA molecules. Now we have to create a legend for what these things are going to look like. So I'm going to draw a box which will be H plus, and then attached to that I'll do a circle which will be the A minuses. That equals HA. So a box with an H plus is just equal to H plus. A circle with an A minus is just the A minus anion. And then we'll do, let's make it a triangle, and that'll be the hydroxide ion. Okay, there are 4 really important points in the titration. Initially, what is this going to look like? Well, initially, I have 4 HAs. That's my initial concentration. And I can do H plus A minus, H plus A minus, H plus A minus, H plus A minus. Some people would do the shapes without the labels inside, and I don't like that. I want to make it really obvious what's going on. Even though I've got a legend up here, which is mandatory, I still like putting those labels in there. So what's the midpoint? The midpoint is when I've consumed half of my original species. So that means I've still got 2 HAs. But I'm also going to have 2 A minus. And I am omitting water at this point. Water would just make this way too complicated and too busy a picture. Okay? So now at the equivalence point, I have an equal amount of acid and base, which means I have consumed all of the HA, and all I'm going to have left over is 4 A minus anions. When I get past the equivalence point, I'm going to have an excess of hydroxide. I still have the A minuses, don't have any H plus in either of these, but I'm also going to have some excess hydroxide. Okay, so that's what a particulate diagram for a titration could look like. All right, thank you for tuning in. This is Morgan, signing off.